All right. This mini lecture is going to talk about what we call scientific notation. And all scientific notation is a way for us to express really big numbers, big measurements, or really small measurements. So I have two examples given here. One of a really long distance, maybe something out into a galaxy. Or one that's really tiny on the nanometer scale, even less than the nanoscale. So if I were going to present these numbers, or if I were going to do math in my calculator, this would be a lot of zeros to keep track of, prone to mistakes. It would be really hard to read as a consumer, to read something and get an understanding with all of those zeros. So what do? We represent it in what we call scientific notation. And scientific notation is a base 10 idea. It means I can represent a number that I would then multiply by 10, a lot of tens, 10 to the power, to give the number that I'm actually representing. And that's just shifting the decimal place. So what do I mean by that? Well, we're going to talk about this top number here first. If I wanted to convert this number into scientific notation, in scientific notation, traditionally, we put one number in front of the decimal place. 2. Then we put our decimal, and we put every significant number after that. 1, 3. So if you want to go back to talking about significance, check out that significant figures video. So I have 3 integer values here, 3 significance, a lot of zeros. There's no decimal place at the end, so those are not significant. So I typically will use scientific notation with just a single digit in front of the decimal, and then the remaining significant digits after the decimal. Now, how do I go from this number to this number? Well, I have to multiply it by tens, lots of tens. How many tens? Well, 10, remember, shifts a decimal place. So if my decimal was here, as in my example, I would be shifting it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I would have to multiply 2.13 times 10 to the 17th to get this number. Shifting that decimal point by 10 to the 17th, 17 times to go from this number to that number. This is scientific notation. It makes it a lot easier for me to write a really big number. What if I want to write a really small number? Well, what would I have to do to this number to represent it in a power, multiplying by a power of 10? Well, again, I use my significant digits, 32, so 3, 1 in front of the decimal, 0.2. And I'd have to multiply it by 10, but in the other direction, divide by 10, right? How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Divide by 10, then divide by 10 again, then divide by 10 again, 12. That's the same as multiplying it by 10 to the negative power, minus 12. So again, this is my scientific notation to write a really small number. I can either write a big number by multiplying it by 10 to some power, or a really small number by multiplying it 10 to the negative power. Scientific notation makes things really easy to look at. There's a lot and less mistakes, not a lot of zeros. We can also go from scientific notation back to regular notation in some cases. So let's do a few examples of that. If my number was 3.612 times 10 to the 4th, scientific notation, one number in front of the decimal, and then the significant numbers after, and then a multiplier by 10, 4 times. Well, I would move my decimal place over 4 spots. 1, 2, 3, 4. There's a 0 missing there. this number then must equal 3612, 0. So I would add that 0 over. Or if I had a number that was 2.61 times 10 to the negative 6th, well, that tells me I'm going to move my decimal places to the left, or divide by 10 6 times. 1, 2, 3, 4, 5, 6. And I would fill those in with zeros, and my number would be 0.1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 2, 6, 1. So scientific notation is just a different way to represent numbers that we then multiply by powers of 10 to go from really, really big to something that's manageable, or really, really small to something that's manageable. There's another way these are written that I want to make you aware of. So we might see something that says 2.13 times 10 to the 17th. We also use the lowercase letter e. So this is also written in many times as 2.13e 17. This e is representing times 10 to the power that's given in that number. So I want you to make you aware that this is a shorthand notation for 10 to the, times 10 to the, all right? This is going to be very important. You're going to see that notation on problems, in your textbook, and in things, practice that you might find elsewhere. In addition, depending on your calculator, Texas Instruments, for example, if you wanted to do scientific notation and do math on that in your calculator, it uses a button that has 2 capital E's. That's the scientific notation button that is representing times 10 to the, and then you would put in the power of 10 that you are using for your calculation. You obviously can also do the times 10 caret 17. So just make sure you understand how your calculator works. Please feel free to reach out to me if you would like me to help you figure out the calculator scientific notation. Every calculator is different. Mine happens to be 2 capital letter E's. This notation you will see a lot, so I want you to familiarize yourself with that. Lowercase e with the number means 2.13 times 10 to the 17th. And again, just really slick ways to show big numbers and really, really small numbers. All right, good job.